araw! Kumusta kayong lahat? Maraming salamat sa Diyos sa isa na namang napakabuting araw at pagkakataon para matuto. Muli, ako si Teacher Royce at hayaan nyo na gabayan kayo at tulungan upang gawing ang math ay maging madali lang. Simulan na natin! Sa araw na ito, pag-uusapan natin ang mga sumusunod. Number 1, illustrating polynomial functions. Number 2, behavior of graphs of polynomial functions. And number 3, problem solving involving polynomial functions. By definition, a polynomial function is a function of the form p of x equals a sub n x raised to n plus a sub n minus 1 x n minus 1 plus 3 dots plus a sub 1 x plus a sub 0. A sub n is not equal to 0. N is non-negative integer. A sub 0, a sub 1, up to a sub n are real numbers. Those numbers are called coefficients. And a sub n x raised to n is the leading term. A sub n is the leading coefficient, and a sub 0 is the constant term of the polynomial function. A polynomial function may also be written using other notation such as f of x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus 3 dots plus a sub 1 x plus a sub 0, or y equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus 3 dots plus a sub 1x plus a sub 0. The degree of the polynomial is determined by the highest power of its term. Here are some examples. The first one, we have p of x equals 2x raised to 3 minus 5x squared plus x plus 7. The polynomial function has 4 terms, namely 2x raised to 3 minus 5x squared, x, and 7. The highest power of its term is 3. Therefore, the degree of the polynomial is in the third degree, and the leading coefficient is 2, and the constant term is 7. Second example, polynomial function f of x equals negative 3x raised to 4 plus x raised to 3 plus x. The polynomial function has 3 terms, namely negative 3x raised to 4 plus x raised to 3 plus x. The highest power of its term is 4. Therefore, the degree of the polynomial is in the fourth degree. The leading coefficient is negative 3, and the constant term is 0. Remember, always arrange the polynomial in descending order with respect to the exponent. Example number 3, the function f of x equals 3x plus the square root of x minus 2. This function is not a polynomial function since the term square root of x is expressed as x raised to 1/2. The function will be written as f of x is equal to 3x plus x raised to 1/2 minus 2. Fourth example, the function p of x equals x raised to 4 plus x raised to 3 plus 2 over x. The function is not a polynomial function since the term 2 over x is expressed as 2x raised to negative 1. The function will be written as p of x equals x raised to 4 plus x raised to 3 plus 2x raised to negative 1. Dumako naman tayo sa graph behavior of polynomial function. Ito ang mga kailangan nating obserbahan at tandaan. Una, the leading coefficient of a given polynomial function. Alamin ninyo kung ito ba ay greater than 0 or positive number or less than 0 or negative number. Obserbahan din natin at alamin ang degree. Kung ito ba ay even or odd. Ngayon, tingnan natin yung first example. If the leading coefficient is greater than 0 or a positive number and the degree is an even number, gaya ng polynomial p of x equals x squared, the leading coefficient is 1 and the degree is in the second degree. So the behavior of the graph will be rising to the left and rising to the right, and it has one turning point. To get the number of turning points, just subtract the degree n by 1. The degree of the given polynomial is in the second degree, so 2 minus 1 equals 1. So the graph of the given polynomial will have one turning point, as shown in this figure. Rising to the left, rising to the right, and it has one turning point. Next example, if the leading coefficient is less than 0 or negative, and the degree is even. So we have the example polynomial p of x equals negative x squared. The leading coefficient of the given polynomial is negative 1 and the degree is in the second degree, which is even. The behavior of the graph of this polynomial function is falling to the left and falling to the right, and it has one turning point. 2 minus 1 equals 1. So here is the illustration of the graph of the given polynomial p of x equals negative x squared, falling to the left, falling to the right, and it has one turning point. Pangatlo, if the leading coefficient is greater than 0 or a positive number and the degree is odd. So we have the example f of x equals x raised to 3. The leading coefficient of this function is 1. And the degree is in the third degree, so that is odd. for the behavior, the graph will be falling to the left and rising to the right. And the graph will have 3 minus 1 equals 2 turning points. So here is the illustration of the graph of the given polynomial f(x) equals x raised to 3. Falling to the left, rising to the right. And it has 2 turning points. So the graph turned twice. Approximately, nandito at nandito ang mga turning points. Pang-apat, if the leading coefficient is less than 0 or a negative number, and the degree of the polynomial is odd. So we have the polynomial function p of x equals negative x raised to 3. The leading coefficient of the function is negative 1. And the degree is in the third degree, which is odd. So this is the behavior of the graph of the polynomial function. It is rising to the left and falling to the right. And it has 3 minus 1 equals 2 turning points. So here is the illustration. The graph of the function p of x equals negative 3 x raised to 3 is rising to the left and falling to the right. And it has 1, 2 turning points. Sana ay nakuha at naintindihan. Ito pa ang karagdagang example. Let us try to sketch the graph of the polynomial function y equals x raised to 4 minus 5x plus 4. So the degree of the polynomial function is in the fourth degree. So that is even. The leading coefficient of the polynomial function is 1. So that is greater than 0 or a positive number. So the graph will be rising to the left and rising to the right. So it will be having 4 minus 1, 3 turning points. For the zeros of the function, we will get negative 2, negative 1, 1, and 2. For the y-intercept, we will obtain y equals 4. And here is the graph of the given polynomial function. Rising to the left, rising to the right, and it has 1, 2, 3 turning points. And here are the zeros of the function or x-intercepts. Negative 2, negative 1, 1, 2. And we have the y-intercept at 4. Ngayon naman ay dumako na tayo sa problem solving involving polynomial functions. Tingnan natin ang given problem. Bukana Resorts Club is a booming natural spring resort in Cavite. It has 5 swimming pools beside a river. The owner is planning to construct a new swimming pool with a maximum capacity of 2,000 cubic feet of water. If the volume of the water in the swimming pool can be modeled by using the function v of t equals t raised to 3 plus 4t t squared plus 175t, where t is the number of hours it takes to fill the swimming pool. Letter A question: what is the volume of the water after 1 hour? And letter B: how long will it take to reach the maximum capacity? Subukan natin. Alam natin that the maximum capacity of the new swimming pool to be built is 2,000 cubic feet of water. And the volume of the water is V of t equals t raised to 3 plus 40t squared plus 175t. Again, where t is the number of hours it takes to fill the swimming pool. Subukan nating sagutan ang letter A question. What is the volume of the water after 1 hour? So, if the number of hour t is equal to 1, then by substitution, we will be having v of 1 equals 1 raised to 3 plus 4t times the quantity 1 squared plus the product of 175 times 1. So we will obtain 216 cubic feet. After 1 hour, the volume of the water will be 216 cubic feet. Question letter B: how long will it take to reach its maximum capacity? From the given, we all know that the maximum capacity of the new swimming pool is 2,000 cubic feet. So by substitution, we will have the equation 2,000 equals t raised to 3 plus 40t squared plus 175t. Adding the additive inverse both sides of 2,000, we have the equation 0 equals t raised to 3 plus 40t squared plus 175t minus 2,000. Now we are ready to compute for the rational roots of the resulting polynomial equation. So by synthetic division, the coefficients are 1, 40, 175, and negative 2,000 respectively. So from the possible rational roots of the resulting polynomial equation, I will choose 5 first as my divisor. Now let us proceed with the synthetic division. To bring down the first coefficient, multiply it by the divisor 5. Write the result under the second coefficient, then get the sum. 45. Multiply the sum by the divisor 5, that is 225. Place it under the third coefficient, then get the sum. 400. Multiply it again by the divisor 5, and place it under the last coefficient. So then get the sum. So we will obtain a sum of 0, meaning 5 is one of the rational roots of the resulting polynomial equation. Meaning t minus 5 is a factor of the resulting polynomial equation. And here are the coefficients of the depressed equation. So I will now rewrite the resulting polynomial equation. So So we will have 0 equals t minus 5 times the quantity t squared plus 45t plus 400. So based from the results, the other roots of the resulting polynomial equation are irrational. So meaning, ang kukunin lang natin ay ang 5, which is the only rational root of the polynomial equation. It means it will take 5 hours to fill the pool to its maximum capacity of 2,000 cubic feet. Maraming salamat sa inyong panonood at pakikinig. Nawa ay natulungan ko kayo upang mas maunawaan ninyo ang inyong lesson sa mathematics. Gusto ko ring magpasalamat sa patuloy ninyong pagsuporta sa ating Facebook page at ang ating YouTube channel. Kung nagustuhan nyo at natulungan kayo ng aming mga videos, inaanyayahan ko kayo na mag-like at mag-subscribe sa ating YouTube channel. At huwag rin kalimutan na pindutin ang notification bell para lagi kayong updated sa mga videos na na-upload natin. Maraming salamat at paalam!